My name is Steve, and I'm going to talk about building geospatial apps with the WhirlyGlobe-Maply toolkit. First, I'll talk about the toolkit itself, a little bit of its history, and some of the apps that use it. Then I'll go into specific features and how they work, and then I'll wrap it up. The WhirlyGlobe-Maply toolkit is an open-source, mobile-first geospatial display toolkit. What that means is that it can implement both a 2D flat map and a 3D interactive globe for iOS and Android. It's based on OpenGL ES, and as a result, it's very fast. It can do either 30 or 60 frames a second, depending on your data sources and depending on the mobile device you're running on. It has an Apache 2.0 license, which makes it very friendly for use in commercial projects. It's been going for nearly 5 years, and as each release comes along, we get a lot of new features. We're trying to do more releases in the future, and with fewer features, we'll see how that goes. Now, there's 4 main groups that use the WhirlyGlobe-Maply toolkit. One is weather apps. There are a number of popular weather apps that use it. Another is 2D or flat maps. Then there are the aerospace apps. These are often aviation related. And then there are education apps, and we'll go through an example of each of these. One of the most prominent users of the WhirlyGlobe-Maply toolkit is the DarkSky app. This is a very popular weather app in the US, and it can show you information about weather over the whole world, as well as weather in your specific location. And what it's really famous for is giving you specific predictions about rain or snow in your area. But it also, a few years ago, added this display mode where you can see radar data and temperature data that cover the whole world, or the areas that you're interested in. It's very popular in the US, and to a lesser degree, I think, in the UK, where it has high-resolution data. Now, there are a lot of fancy things going on in this app, but the bulk of the functionality you're looking at is in the toolkit itself. And we'll go through some of what that is. Here is a traditional map app, and this is a very popular app for backcountry types, people who like to go hiking or off-roading on trails that aren't necessarily near civilization, and they will often take their maps with them using this app, which is called Gaia GPS. And it has a very dedicated community of people who will test these things out and give feedback to the developers, and they'll pass it on to me. It can do both traditional image-based maps and vector-based maps as well. This example is one of the aviation apps that uses the WhirlyGlobe-Maply toolkit. It's called FlyQ EFB from Seattle Avionics, and it's one of the popular aviation apps on the Apple App Store. Now, aviation users like to display a lot of different content all at once. I find their maps somewhat incomprehensible myself, but they seem quite happy with them. And these apps will really stress what the toolkit can do, really push the limits. And in this case, you can see they're running 2 different windows often, and they'll close those sometimes. The app will go into the background, and they're very sensitive to crashes and memory and power usage. So it's a great test case for a lot of different features. This is National Geographic World Atlas. And the last version of the World Atlas app switched to the WhirlyGlobe-Maply toolkit, and we were able to do some really interesting stuff there. Of course, it's a great app with really interesting data, and it should be noted that the part of it that Mousebird Consulting did was just the globe. The lovely interface itself was created by Raleigh Interactive. Now, one of the interesting things about National Geographic datasets is they have these very elaborate text layouts with their own fonts and text that's rotated, often following a curve or just placed by hand. And their workflow required us to take PDF and do something with it. What they'd done in the past is render the PDF as gigantic images, chop it up into little pieces, and then upload those little pieces somewhere and download them to the app as needed. Instead of doing that, what we did was rip the text out of the PDF, as well as the symbols, and then transfer those via another path. And what this meant is that the database was much smaller, because the images could be a lot smaller, and the text and the symbols are much, much sharper. And this resulted in a really nice look and feel, as well as a much smaller set of databases which could be downloaded much more quickly. Now, we used Mapbox. Mapbox is cloud storage for the vector tiles, although we're not using any of their styles. And each of the tiles comes down as a collection of base images, symbols, boundaries which are invisible but allow for selection, and text placement. So let's go into some specific features of the WhirlyGlobe-Maply toolkit. We'll start with image layers, which is one of the most common ones. We'll take a look at labels and markers, then vector data, both tiled and not, selection, which kind of goes with all of those, annotations, which is something you will typically pop up when you select, particle systems, and 3D interaction. Image layers are one of the most common features that people use in the toolkit. And you can implement these in your own toolkit fairly naively. If you just, as a piece of image comes in, you just kind of create some geometry for it, you collect them all up, and then when you're ready to render, you just render them individually. That'll work pretty well, particularly on modern hardware. We don't do that though, we go much farther. If you want to make rendering fast on mobile devices, then you need to collect your textures up into what are known as texture atlases. And this is something game developers will do all the time. So you put a lot of little textures into a big texture, and then you organize your geometry along similar lines. And this is an example of what a whole bunch of tiles from a typical base map would look like as they came in. So we organize these individual tiles into large dynamic texture atlases, do similar things for the geometry, and then we can render a base map in just a few draw calls. And again, for most cases, this really doesn't matter. It's when you start getting tricky that it does. When you have a lot of overlays, you have a lot of individual map layers being rendered. And there are a number of tricks that we'll do to get the size of these down. So for example, in this example, which is DarkSky and in a high resolution mode, we're actually rendering indexed images and using the shader to calculate color. But you can also do compressed images, you can do 16-bit or 8-bit images. There are a lot of different tricks you can use to get the size of your image data down for an image layer. Now the image layers are very flexible, and in this example from the FlyQ EFB app, we've attached a custom shader to an image layer and also custom data. So in this case, what's happening is the shader is at every point on the screen deciding if a given pixel is above, below, or close to the plane. And if it's above the plane, you'll get an orange warning. If it's close, you'll get yellow. And if it's far enough below, it'll just leave it alone. And this is all implemented through a custom shader that is added to the toolkit at a high level without having to dig into the internals. There are also some map-related features that are of interest. So for example, here we're doing infinite panning, which basically lets us kind of scroll to the right or to the left infinitely over the whole world. And it's a useful 2D map feature, and it's harder than it looks. Other features that are useful are markers and vectors, and these sort of have obvious uses for maps. For markers, we can draw an enormous number of 2D markers or 3D markers. And for vectors, we can draw vector outlines, filled, not filled, with height or not with height, with individual textures, and all available for selection. Markers also have an interesting property in that they can have motion. So you can specify a beginning point and an end point for markers and labels, and a velocity, and it will interpolate between the two. These are implemented via a shader, very low level, which means that we can draw an absolutely enormous number of them. And there are some cases where that's useful, for example in this app here. One of the consequences of that technology is that we can also do marker clustering. So these are markers that we've added with a simple group ID, and then the system itself will group those together if they would overlap on the screen. And since we can do both a globe and a map, and 3D, and we can also do both of those in 3D, that means that we have to do the marker clustering in real time, and that gives you a lot of flexibility. So we can also do particle systems, and these are great for weather apps. This is the example from the test app itself, and at this time there are no weather apps that have shipped with this, but the ones that are under development look a lot better than this example, although this isn't too bad. And what we're displaying here is wind information. Basically, we have a tile set which describes the wind values in U and V with velocity, and we look up each of those values for each particle, and the particles last about 2 seconds. There are 500,000 of them in this example, and the process of creating them is much harder than drawing them. Drawing particles is actually pretty easy on mobile devices. Particles are pretty simple to draw, their shaders are pretty straightforward. It's the creation that is the hard part. And in this example, we have a separate thread going through and identifying for each 500,000 particles, where they land on the Earth, what their velocity is, and then creating color and other values based on that. In this example, we're showing LiDAR point data. And in this case, it's 2 million points from a 12 million point data set. And the data set is from the Pacific Northwest. It's the Mount St. Helens. So what we're doing here is displaying a color value at each point, and each point has a 3D value as well. And this is an interesting example of the other kinds of data sets you can display. This is a work in progress, so even though the point display is in the toolkit now, we're still working on data formats for efficiently tiling this compressed data. This is an example of an app that does a lot of 3D interaction. It's from the National Air Traffic Control System for the UK. And it starts out in 2D mode, and they're basically displaying tracks for planes as those planes move around their airspace and the world. And you can move around and tap on different planes, see where they're coming from, where they're going to. And again, Mousebird Consulting here did just the 3D globe and some of the 3D features. All the 2D stuff was done by NATS itself. And they did a really nice job on this app. So 3D interaction isn't always useful. It's really useful depending on what you're doing. But this is a case where it really shines, because you can see how the different planes relate to each other within an airspace and the different levels that they occupy. And then you can move around on tap on things and see how their tracks, where they came from and where they're going to, interact with the airspace itself. And it really shows some interesting things about that airspace, including how the planes will move up and out, and how different planes will just go over without really interacting with the ground, the airspaces that are closer to the ground. Now, one of the nice consequences of having these aviation app users is that they will really push the limits of what the toolkit can do. The weather apps are great in their own way, as are the map apps, but aviation users really like to display absolutely everything all at once. And that has really consolidated our memory management and thread cleanup and a lot of threading related issues. So you can hit the toolkit from any different thread or dispatch queue on iOS, and similar on Android. And it's really very, very resilient to that. So it's very fast if you have a multi-core mobile device, of which there are a lot these days. And it's just very, very efficient. And in fact, with the latest version, 2.4, some of my bigger users have released their apps at the same time. So there are two examples, Gaia GPS and FlyQ EFB. Both went through a release cycle about the time we were doing 2.4. And so we used their Crashlytics accounts to find a lot of existing bugs. And they were very kind to run multiple versions through their beta testing networks, both of which are pretty good. And we found a lot of interesting bugs and cleaned up a lot of strange corner cases for both of those apps. And they both tend to be concerned with memory and power consumption. Android support tends to lag behind iOS. For whatever reason, most of my users are based on iOS, but the weather apps are really pushing towards Android. So the regular and animated image layers are working currently, simple label and marker support, basic vector support, and both the map and the globe are there. They haven't reached the point where I'd say one of the more complex aviation apps could port to Android, but they're good enough for a lot of applications, and Android is definitely coming along with more support coming in 2016. So the roadmap for the future, at least as it looks at the moment, we're expecting more vector tile support. Those are becoming very popular. Support for more advanced cartography. Vector maps are becoming very interesting, and there are a lot of different uses for those. Additional moving object support, I hope. That's an interesting area that I'd like to further explore. Integration with third-party map toolkits is also ongoing. There's a lot of low-level technology within WhirlyGlobe-Maply that we're hoping to see used in other people's toolkits as well. Android is going to be big in the future as well. And there's a feature testing framework that will help us do releases more often by being able to test new features more quickly. There are a lot of resources for getting started on your WhirlyGlobe-Maply app. There's a nice set of tutorials, there's reference documentation, And of course, everything is available on the GitHub repo, including a set of issues where you can create your own. There's an active community of users who will also answer a lot of these issues before I get to them. In terms of what Mousebird Consulting does, we make the WhirlyGlobe-Maply toolkit, which we give away for free. So obviously that's not a great business plan. What we do is we consult based on that toolkit. So people will ask us to integrate the toolkit into their apps as well as provide new features. There's also a support contract. You can get a yearly support contract for maintenance and bug fixes, and you can ask as many questions as you like, and there's training available too. So in this video, what we've gone over is the WhirlyGlobe-Maply toolkit, what kind of state it's in, what it can do, the individual features that may be useful to your map, aerospace, or education, or weather app, and the roadmap for the future. There's also some contact information here at the bottom, though I'm easy enough to find. Feel free to send me an email or drop me a line on the issues in GitHub.